Hi, let's take a look at some problems from section 5.3 homework. I've selected to work problems from my math lab. They really do represent the problems from the textbook. So the first problem is number 2 from section 5.3 homework. It is to convert to a logarithmic equation. We have e to the negative 5 is equal to k. So remember this equivalency that log base a of x is equal to y is equivalent to a to the y is equal to x. So we would write this in terms of log. Our base in this case is e. And remember the log is always equal to the power. So this is log base e of k is equal to negative 5. And check, e to the negative 5 has to equal k. Now log base e is the same thing as natural log of k is equal to negative 5. So you would need to enter the k and the negative 5. To convert to an exponential equation, 3 is equal to log base 2 of 8, so that means that 2 to the third power is equal to 8. And it says to type in the exponential form, so you would need to enter the 2 to the third in the box. Continuing that, convert to an exponential equation. Remember that log of 0.001 equals negative 3. Log without a base is understood to be base 10. So this would mean 10 to the negative 3 is equal to 0.001. So you're going to enter 10 to the negative 3 in the box. Number 5 is to solve log base 5 of 125 is equal to x. So converting that means 5 to the x is equal to 125. Well, we know that to solve an exponential equation, we can convert both sides to the same base if that's possible. It is in this case. 125 is the same thing as 5 cubed, so therefore x has to be 3. Log base 4 of x equals negative 2 means that 4 to the negative 2 is equal to x, but 4 to the negative 2 is the same thing as what? 1 over 4 squared, or 1 over 16 would be the value of x. Log base x of 27 equals 3 halves would mean that x to the 3 halves is equal to 27. Okay? So to get the x by itself, we're going to need to raise both sides to the what power? To the 2/3 power. So this would give us that x is equal to, 27 to the 2/3 is really the cube root of 27 squared, which would be 3 squared, or 9. Now, this problem says to find the pH from the given hydronium ion concentration, a solution that has 1.3 times 10 to the negative 4. Well, pH is a scale that measures if something is an acid or alkaline. So the formula for this is that the pH is equal to the opposite of the log of the hydronium ion concentration. So to find the pH here, we're just going to use our calculator to do the opposite of the log of 1.3 times 10 to the negative 4. And if we plug that into the calculator, the opposite log 1.3 times 10 to the power of the negative 4, we get, what did it say, round to the nearest tenth, so that would be 3.9. So 3.9 would be an acid. Okay, 7 is neutral, less than 7 is acid, greater than 7 would be alkaline. Find the hydronium ion concentration for the substance with a given pH. Okay, so now we're told 3.8. We've got to find out what the hydronium ion concentration is. So this one is a little bit involved, not too bad. So we know what pH is equal to the opposite of log of the hydronium ion concentration. So if you want to call that, let's say x, so we would have our pH, which is 3.8, is equal to the negative log of x. Well, we need to isolate the log first, so we would have negative 3.8 is equal to what? Log of x. And then just remember that our base is what? 10? Yep. So we're going to have what? 10 to the negative 3.8 would be equal to x. And if you do this on the calculator, what is 10 to the negative 3.8? Okay, you're going to see on your calculator that becomes 1 point, what does that round to the nearest tenth, 1.6. And then you'll notice the e negative 4. So this really means 1.6 times 10 to the negative 4. Okay, and that would be your answer. Another application, suppose that $2,000 is invested in an account that pays interest compounded continuously. Find the amount of time it would take for the account to grow at 5.25%. So compounded continuously is A is equal to P e to the RT, PERT, some people call it. So we know we're investing what? $2,000. Oh, you know what? I took out my problem here, so let me just make up a number. Let's say we want it to grow to, I don't know, $6,000. Okay, so we're going to say $6,000. 2,000 e to the, our rate is 0.0525. We don't know our time. So we're going to have to divide both sides by 2,000, right, to isolate the variable. So we would get 3 is equal to e to the 0.0525 t. Now remember what we can do to get the variable out of the exponent. We have to use logs, and since we have a base of e, we want to use the natural log. So if we take the natural log of both sides, remember that on the right side, the natural log and e have the same base, so that just cancels each other out to give us what is in the power. And finally, to solve for t, we're going to divide both sides by 0.0525. So using the calculator, natural log of 3 divided by 0.0525 is going to be 20, said round to the nearest tenth, 20.9 is t. So take about 21 years for that amount to grow to $6,000. Now we're going to use the properties of logs to rewrite these expressions as a sum, difference, or product. So we have log base 4 of 2y over z. Well, first recall that the log of a quotient is the difference of the logs. So this would be log base 4 of the numerator, 2y, minus log base 4 of the denominator, which is z. Now, in the first log, we have a product, so we can expand that further. The log of a product is a sum of the log of each of the factors. So this would be log base 4 of 2 plus log base 4 of y minus log base 4 of z. So which one is that? Part C, log base 4 of 2 plus log base 4 of y minus log base 4 of z. Continuing that same type of thing, use the properties to rewrite. So we would have, again, a quotient begins by writing the difference, log base 4 of 7 on the square root of t minus log base 4 of r. Well, in the first term, we have a product inside the log, so we can expand that to be log base 4 of 7 plus log base 4 of the square root of t. But remember, the square root of t is really t to the 1/2 power, and then minus log base 4 of r. So the final step, we can take down the power inside the log expression. So we would have log base 4 of 7 plus 1/2 times log base 4 of t minus log base 4 of r. continuing, we have log base 3 of the square root of zt over 6. Well, understand that the main operation here is that we have this quantity, this quotient zt over 6 raised to the 1/2 power, right, the square root. So we're going to have to first get rid of that. So this would be 1/2 times the log base 3 of zt over 6. So now we can expand that, but just keep in mind the 1/2 has to be multiplied by everything that follows. So we'd had 1/2 times the log base 3 of zt minus log base 3 of 6. So we can expand the product to be log or 1/2 times log base 3 of z plus log base 3 of t minus log base 3 of 6. And then in the last step you can distribute the 1/2 to each of those terms to get 1/2 times log base 3 of z plus 1/2 times log base 3 of t minus 1/2 times log base 3 of 6. Okay? And which one does that correspond to? Make sure you distribute the 1/2 through, and it looks like part B, is that right? 1/2 log base 3 of z plus 1/2 log base 3 of t, yep, minus 1/2 log base 3 of 6, that's correct. Now we're going to use the properties now to rewrite as a single log. So we have a sum of logs, so we can rewrite that as the log of the product. So this would be log base 10, but we don't have to write the base 10, of x plus 2 times x minus 2. Now if you want to inside the log, you can simplify that. X plus 2 times x minus 2 is really the difference of two squares, x squared minus 4. And the last two problems, if we have 3 times the log base c of x minus 5 times log base c of y to the 4th, we can rewrite that as a single log. Dealing with each term, first we need to bring up that coefficient to write this as a log base c of x cubed minus the log base c of y to the 4th raised to the 5th power, right? That power of 5 comes up. So we would have log base c of x cubed minus log base c of y to the 20th, right? A power to a power we multiply. Now we can use the subtraction sign to convert this to the log base c of x to the 3rd over y to the 20th. And the last problem is to use the logs, or use the change of base formula to calculate log base 9 of 12. So remember that the log base a of x is the same thing as log x over log of a. So that is a common log, or we can use a natural log. Oops, not natural log of x, natural log of a over here. So log base 9 of 12 would either be log of 12 divided by log of 9, or we can certainly compute that as the natural log of 12 over the natural log of 9. Keep in mind what I said earlier on the lecture video, the base has to go in the basement, right? So we always put the base in the denominator. Now, using the calculator, we compute log 12, you have to close parentheses, then divided by log 9, close parentheses, equals, it says round to 4 decimal places, so we would have 1.1309. Okay, so that concludes the homework for this section. If you have any questions, you know what to do. Thanks. Bye-bye.